So EAVOR Technologies were founded about 7 years ago. I'm one of the founders. There's a handful of us. We had an idea, a different way of extracting heat from the earth. A lot different than what people traditionally call geothermal, or what traditional geothermal is. We have a very different way of extracting heat from the ground. It's not a new concept or new idea as to how we would do this. It's just that technology in the last, well, certainly 10 years and really the last 15 years, typically born in Alberta oil and gas technology, a lot around the oil sands, or what's called SAGD, the new techniques and new drilling methods, thermodynamic properties of how they do the work that they do in northern Alberta. That technology makes what we do economic or viable or possible. So in traditional geothermal, you're looking for a source of heat and an aquifer in the earth. You're looking for a certain set of conditions. You're looking for a certain constellation, we sometimes call it, of conditions in the subsurface. Much like oil and gas, you need to drill and find that perfect spot, or that spot that's going to work for what you're trying to do. Whatever does differently, what our key differentiation is that we don't have to have a certain set of conditions in the earth. As you go deeper into the ground, as you go deeper into the earth, it simply gets hotter. This is everywhere. It's always like this. We build a radiator into the earth rather than a system that would extract fluid, extract or produce heat or produce water from a certain point in the earth. We just simply build a radiator into the ground. This is not a new idea. This has been thought of long ago. What's changed and different is that the technologies, usually born mainly in oil and gas, a lot of which is here in Alberta, the SAGD industry and so on, is they've figured out different ways to drill to extract, in this case, in their case, hydrocarbons from the ground. How to position wells, how to place them in the right spot, how to keep them the right distance from each other. All these technologies that have been developed in the oil and gas industry can be repurposed or reused for what we want to do, which is just building this radiator into the earth. When it comes to reducing emissions, it's all about efficiency. Okay, so extracting heat from the earth, heat is converted into electricity through standard practices and ways of doing it. Also, heat is used for direct heating. We have a way of extracting heat from the ground and using it directly for heating or transferring it into electricity. So the reduction of emissions is really just based on how electricity would be generated otherwise. So otherwise, and here in the province of Alberta and other places around the world, you would have some other sort of heat source. That's usually a hydrocarbon-based heat source. You burn that hydrocarbon, you make the heat, you use that heat and you transfer it and you generate electricity from that heat. With an EAVOR loop, we're simply extracting the heat directly from the earth. There is no hydrocarbon burn, therefore there is no emissions of any kind, CO2 or otherwise. So we're simply taking the heat from the earth and using that heat directly to make electricity, or using that heat directly for heating purposes. The alternate would be to burn a hydrocarbon, have an emission, and make that same heat. It's just a different way of getting to the same location. We're making electricity out of heat, we're using heat for heating, and we're not doing that by burning a hydrocarbon. It isn't so much that we are pulling hydrocarbons out of the equation, we just are putting electricity or energy into the market in a way that doesn't have an emission. On a technical basis, our technology can be applied absolutely anywhere. And we really do mean anywhere. The earth has a heat gradient. The deeper you drill, the deeper you get into the earth, the hotter it becomes. Now there's some places around the world that heat uptake or the heat gradient is higher. You achieve a higher temperature at a shallower depth. So other places around the world where it's a little bit more cool, you have to go much deeper to get to, say, the temperature that you're looking for to do. But what is certain is the deeper you drill into the earth, the hotter it is. There's other things that have to be considered. So technically speaking, if all you are worrying about is technical, then it works anywhere, and I've said enough about that. The deeper you drill into the earth, the hotter it gets. Depending where you are, tells you how deep you have to drill. You can make electricity, or you can make heating from that. But there's obviously a lot more to it than just the technical side of things. There's the economics of it. Some parts of the world where it might be nice and warm, or unfortunately it might be a little bit cooler, you also have to look at what the costs of drilling are going to be. The cost of drilling, the cost of the operations, building and constructing the system. Some places in the world where you typically see oil and gas operations, where there already is a lot of drilling going on, the costs of doing this are relative to other places in the world pretty good. There's availability of drilling rigs, there's services, and everything that we would normally need to drill a well and to drill the type of wells that we drill are available into those locations. And so therefore, usually the price of doing so, the cost of doing so is much lower. However, there's another thing to look at, and that's the revenue side or the profit generation side. You're selling electricity, you're selling heat. Well, that's wildly different wherever you go around the world. So what EAVOR's doing at our very beginnings, what we're doing now, is we're looking for locations. Well, it can work anywhere in the world. We're looking for locations that have the right combination of a temperature gradient. We'd prefer a higher temperature gradient. We'd prefer a location where there is access to drilling rigs, or there already is a hydrocarbon business or an energy infrastructure that is in place for us to draw upon, so the costs aren't so expensive. And we'd also like that location to be a place that has high energy prices. So finding a combination of those three things is actually quite difficult. But we need to try to do that in the very beginning, because in the very beginning, the costs are going to be expensive almost wherever you go. What we need to do is practice. We need to move down what's called a learning curve. Well understood concept and idea. The more you practice, the more you try and have failures and challenges and overcome them, the more and more you learn, and the less and less expensive it becomes. So once we're down the learning curve far enough, the question of, well, what is the market price for energy, or what is the cost of drilling, or what is the heat gradient in those locations becomes less and less important and less relevant. We have a plan to practice in the places that do have a good combination of price, heat gradient, and costs, low costs. Practice in those locations, come down the learning curve so that we can just get right back to that technical part where the economics happen to work everywhere, and therefore technically it can be everywhere, and so we go everywhere. It's a long game solution with a simple and tried and true method to get through this first phase. We practice where the opportunities make the most sense, come down the learning curve, and then apply the technology everywhere in the world. You know, on the technical side, Alberta was from a regulatory or a governmental policy side of things, it's obviously a relatively easy place for us to develop the technology and work with it. The people that are from here are also familiar with the rules and regulations and the policies here in Alberta. They don't always apply straight off to the geothermal things that we're doing, but they were close enough, and we knew how to. Our people know how to work with it here in Alberta. So that's nice. From more of a federal level or a funding level from grants, we have received grants from Alberta and grants from the federal government. We've received investments recently from a large federal capital institution, and we've had in the past. So we've seen a lot of governmental support, policy and regulatory support, in particular in Alberta, and governmental support in the provincial side in Alberta and the federal side in Canada. It's been a good environment for us to leverage support, and not always dollars, but the dollars of course help, but leverage support in general from the Alberta and Canadian governments. So we have a pretty bold long-term overall plan. It's really to transform, redefine the energy stack of the planet. That's a pretty big statement. We have some markers that we put out there for ourselves and try to put out in the industry, not just necessarily EAVOR, but what EAVOR's looking to do, is try to stimulate and bring in a scenario where at some point in the future, I don't know if this is 20, 30, 40, 50, 60 years in the future, we believe there's a way that you could see 1 gigawatt of geothermal energy added to the worldwide grid every single day. That is a massive number, and a goal that is designed to be a goal that would unite us all. How do we look at doing that today? Where do you start? As I've already mentioned, we have a learning curve to come down. So there's these interesting or good and unfortunately rare locations around the world where we need to start, where the economics are just good enough, where we can come down the learning curve and bring in the economics of going just about everywhere. But going just about everywhere is going to require some things that just don't exist right now. One of those things is drilling rigs. There is simply not enough drilling rigs currently on the planet, if they were capable of drilling the type of well we are or not. Just the rig count itself is nowhere near where it would need to be in order to hit the long-term goals that we already have put into place. Also, at this time, we look for great project locations where 1 or 2 or 3 or 4 EAVOR loops could be built in one good spot. A good place to learn and provide some decent economics to start off with, so we can come down that learning curve. Eventually, we're talking about geo-manufacturing, building hundreds of Everloops, looking at a nation, looking at a nation's overall plan as to how it starts to move from hydrocarbon-based or other sorts of power generation or heat and energy generation to eventually switch over to more and more and more of its energy stack to come from a technology such as ours.